Hey Tens! Today we're going to learn about special solutions of equations and how equations look like on a coordinate plane. Some terms to know. A coordinate plane is a grid labeled with numbers and two axes, called the x-axis and the y-axis. This coordinate plane is used to graph equations. And when you write coordinates, they look like this. X, Y. So you have those two axes, right? The x-axis and the y-axis. So what they mean is that the horizontal axis is your x-axis and the vertical axis is your y-axis. And when you write a coordinate, you have to write the value that is on the x-axis first and then the value that is on the y-axis second. So if you have the coordinate, say 5, 3. That means from your point of origin, or the coordinate point 0, 0, you have to go 5 units to the right on your x-axis and 3 units up on your y-axis. Parallel means two or more things that never intersect. You must have heard of these with lines most of the time. And yes, there can be parallel lines, and we'll see how this ties into today's lesson later on. Slope-intercept form is a form of writing linear equations. Again, I'll elaborate on this later on. Alright, let's try some examples with special solutions that are different from the norm. So, 4x plus 17 is equal to 2 times 2x plus 5 in parentheses. Alright, let's try solving this. And you don't need any additional vocabulary for this because you already know how to solve equations like these. So first, let's do the distributive property here and distribute this 2 to the 2x and the 5. So 2 times 2x is equal to 4x, and 2 times 5 is equal to 10. So this is equal to 4x plus 10. And we can bring the 4x plus 17 down. Okay, let's keep going. Let's subtract 10 from both sides and subtract 4x from both sides. Okay, this leaves us with 7 is equal to 0. Now, that's obviously not true, right? Because 7 can never be equal to 0. This signals to you that these two equations have no solution at all. They never intersect. And we'll see when I go to Desmos and show you on the graph what these two expressions look like. Alright, let's try the second one. 7x minus 28 is equal to negative 7 times negative x plus 4. Okay, let's do this. Let's distribute the negative 7 to negative x and 4. So negative 7 times negative x, a negative times a negative is equal to a positive, so that's equal to 7x. Negative 7 times 4 is equal to negative 28. And so this is equal to 7x minus 28. Alright, let's add 28 to both sides and subtract 7x from both sides. And this gives us 0 is equal to 0. This is always true. And this signals to you that these two expressions are completely identical. All real values of x are solutions. So this has, in fact, infinitely many solutions. And I'll put no solution here because that's what it has. Alright, let's head on to Desmos and see how these expressions look like on the coordinate plane. Welcome to Desmos. This is a graphing calculator that is online and free to use. If you want to play with Desmos, I'll put the link in the description below. So, let's see how exactly a linear equation looks like on the coordinate plane. Now, the simplest linear equation you can do is x, or y is equal to x. And this can also be equal to x equals y, because commutative. And this is also equal to x, just x. You can see that these are all the same line, as shown by the different color that is not changing the line at all. And if you see this line here, and you're wondering why exactly do I get this line every time I plug in this equation into Desmos, it's because it's literally plotting all the points that are on that line, that are solutions to that equation. So you can see that this is the x-axis, and let me just label that right here. So the x-axis and the y-axis, you can see that. So if I label them, you can see that this is the x-axis now, and this is the y-axis. And so if we go up through this thing, and you see that this is the origin point. The point where the two axes meet is the origin, and the origin is always 0, 0. So if we want to go and see what points are on this line, we just drag. And you can see that whatever x is, y is. Remember, the coordinates are written as x first, y second. And I can't exactly point them out, so sorry about that. That's what it is. And you can see that if I stop at any point, y is always equal to x. And that's because I've specified it here. Y must be equal to x for this equation to be true. So that's what this is showing. When x is equal to negative 4.23, as shown here, y is equal to negative 4.23 as well. So let's change the equation a little bit. Let's go back to that first equation we were solving for. And let's put in the first expression, 4x plus 17. You can see that this is a different line here now. We're being shown this line right here. And so if I just x these out, this first line will disappear, and we'll be left with this line. So this is the graph of our expression, 4x plus 17. And this is the same thing as y is equal to 4x plus 17, as you can see here. So I'll just delete that. So we have this line right here. And when we write the coordinates that are on this line right here, whatever x is, y will always equal whatever you get when you plug in that x coordinate for x. So if my x coordinate is, let's say, -4, you can see that y is equal to 1. So let's plug in -4 for x. So if we evaluate this, 4 times -4 is equal to -16 plus 17 is equal to our y coordinate, 1. So when x is equal to -4, y is equal to 1. This is what your coordinate does, and it does it for every single real number on the x-axis. So this line actually goes on forever, like this. No matter how far I go, even to the 100,000s or millions or even billions, it's always going to be there. This line is never going to end. And that's the definition of a line. A line goes on forever in both ways. A line segment is the finite one. So let's go back to our default. And you can see that there's this gray dot highlighted here. And when we hover on it or click on it, we get this coordinate, -4.250. This is basically when you plug in -4.25 for x in this expression, we will get 0 for y. And if we go higher, we can see that now x is equal to 0 and y is equal to 17. Well, true, right? If you plug in 0 for x, you get 17 for y, because 4 times 0 is equal to 0, plus 17 is 17. And what these are our x-intercept and our y-intercept. And our y-intercept is quite important, as it enables us to solve for many things, as we'll see later on. Basically, what these intercepts are is when this graph intersects the x-axis and when this graph intersects the y-axis. And if you've noticed that this y-coordinate at the y-intercept is the exact same as this here, yes, you're right. This value is always going to be the y-coordinate of the y-intercept. Let me show you with a different equation. Let's take 5x plus 20. Now you can see that it's a slightly steeper line, and now we see 3 dots. So let's ignore this dot right now and focus on the x-intercept and the y-intercept. Now we can see that when y is equal to 0, x is equal to -4, and when x is equal to 0, y is equal to 20, and you can see that this value matches with this value. It's the same for every linear equation. Alright, let's take that second expression that we had equated to this and gotten no solution from. 2 times 2x plus 5. We can see that we've got this different line over here. And if you'll notice, this is the same as 4x plus 10. You can see that it's the same line. I'm just going to delete that. And if we go closer, you may be thinking that these look like parallel lines. And yes, they are parallel lines. Even if we go this far back, at which point it looks like these have become one line, they're still different. So let's go back to our default zoom, and we can see that they both have different x-intercepts and different y-intercepts. So why these two expressions have no solution is because their graphs are parallel. They will never intersect. So if a line never intersects with another line, meaning that it's parallel to that other line, they will never intersect, and they will never have any real solution. And we'll talk about why they'll have no real solution later. So let's delete these and let's try the second one. 7x minus 28. And so we have this line right here, and our x-intercept is 4, 0. And if we go down, you may have guessed correctly that our y-intercept is going to be negative 28, as written here. So if we put that second expression in, negative 7 times negative x plus 4, you can see, to your surprise, that the purple line has disappeared. But if I click on this, it reappears. But they change color. Again, as I told you earlier, when two equations have the same graph, Desmos will show it like this. If you select them, this line seems to magically change color. And this means that these two lines are the exact same expression. They are completely equal to each other. So every real value of x will be a solution of these two. And we can see that. They even have the same intercept. They have the same y-intercept. If we go down, they're the exact same line. And in the Big Ideas math textbooks, they'll call this an identity, and I've linked the Big Idea math textbooks in the description, so you can check that out. And so this is what we call infinite real solutions. There is an infinite number of real solutions to this equation. Thanks for watching. If you liked this video or this helped you, click that like button. If this didn't help you, click that dislike button. I greatly appreciate feedback. If you want more updates on new videos, click that subscribe button and turn on notifications. If you have any questions related to this topic, put those in the comments below. And remember, the comment section is the equivalent of class discussion, so if you have any answers to any of the questions, you can answer those. If you have any suggestions as to how I can improve my future videos, or even suggestions as to what I should do next, put those in the comments below as well. If I like your suggestion, I'll be sure to include that in the next video and give you a shout out. See you in the next one.